Okay, the period is given for a function of the form y equals the sine of b times x. Write the equation for it corresponding to the given values for the period, which is pi over 6. So just to give you a quick feel, what we have here is a sine curve that looks like this, whose period is pi over 6. So this halfway point is pi over 12, and this halfway point is pi over 24. I've got to make sure I did this right. So it's pi over 24, 2 pi over 24, 3 pi over 24, which really should be reduced to pi over 8. But I just want to give you a feel for what we've got going here. We want to write y equals the sine of something here times x that causes this period to be pi over 6. So the definition of period is 2 pi divided by b. It's kind of my opinion that it's easiest if we just take this statement and solve for b. So b is downstairs in the denominator. So I'm going to multiply both sides by the letter b. And on the left side, I'll have b times p equals 2 pi because these b's would have canceled out over here. Finally, I want to get b alone. I want to find out what it is. So let's divide both sides by the period. And I now have that the letter b can be found by taking 2 pi and dividing it by the period. So remember, the period is defined as 2 pi divided by b, and now all I did was move this over here and that down there. So see, I moved the b over here and the p down here by algebra, means of algebra, and now I can find this value that goes in front of x when I know the period. So I'm going to erase all of this proof, so stop if you want and get it written down. So since my period, and I'm going to leave this formula right here, since my period is pi over 6 for this problem, I'm going to take, to find b, I'm going to take 2 pi and divide it by pi over 6. Now remember, when you take 2 pi and divide it by a fraction, you multiply it by its reciprocal, which is 6 over pi. And so these pi's will cancel out because one's in the numerator and one's in the denominator. And my b value for this problem will be 2 times 6, or 12. See this right here? The equation for this problem is y equals 12x will give us a period of pi over 6. And you can even now just check it. Just see if 2 pi divided by 12 gives you that pi over 6, the period of pi over 6. There are other ways to do this, and I may show these in class, but I think it's almost best if I stick with one way. Here we are now with a problem where the period is 4, and my b value is found by dividing by the period. So I'm going to take 2 pi and divide it by 4, and I'm going to reduce 2 over 4 to be 1 over 2, which is just pi over 2. And it said write a sine curve, so that would be y equals the sine of pi over 2 times x. You got to have that variable x. That represents your angle, so don't lose that. So in number 3, the b value would be found by taking 2 pi and divided by the period, which is 3 pi over 7. So careful, the 2 pi is over 1. And when you divide by 3 pi over 7, you multiply by 7 over 3 pi. The pi's can cancel out again, right there. They can cancel out. That 3 doesn't belong to the pi. They're factors, so you can cancel those out. My numerator, 2 times 7 is 14. My denominator, 1 times 3 is 3. And the curve is y equals the sine of 14 over 3x. And I've played the game called What's My Function and successfully written the equation. So let's now go and take this one step further. Let's play What's My Function. The first figure is a sine curve. This picture is a sine curve, and I want you to fill in the a value, and I want you to fill in the b value to write the equation of this curve. So the a value has to do with this amplitude. So I did this on a TI Inspire, and so I wish for you to see that here is my amplitude. This 1 and this 2 are supposed to represent these important points on this sine curve. So what is that 2 in terms of what we've been studying so far? What's the name of that? You got it, that's the period. So the period is 2 for this problem. So my b value is found by taking 2 pi and dividing by the period, which is 2. So my b value for this equation right here is going to be pi. And what's my amplitude? How high does this curve get? And is it positive? Yes, it is. It's a positive 2. So the equation that fits this curve is y equals 2 times the sine of pi x. Now, if you put this into your graphing calculator, you could hit your trace key right now. Make sure you put zoom trig, or you could actually open the window to go from 0 to about 3 on the x-axis and maybe 0 to 3 on the y-axis, and you'd hit your trace key, and right here when you cross that axis you'd find out that that's x is 1, and then when you got back here x would be 2. So you could find those spots and trace this curve. So you pause now please and do this next one by looking at this and seeing if it says this is a cosine curve. So this is a cosine curve. So I need you to fill in that value based on this y-axis. This is supposed to be representing this high point right here. And this is a negative 1/3 right there. This is 2 pi. This is 4 pi. This is 6 pi. I'll make them dark so you can see them. So you've got to write down what the period is for this curve and calculate b, and then you can see your amplitude's got to do with this 1/3. Pause and then come back. I hope you saw that the period for this curve is 8 pi, because this repeats. Here's the first quarter, next, next, and next. So that's the end. So the period is 8 pi, and my b value would be found by taking 2 pi divided by my period of 8 pi. So the pi's will cancel out, and 2 over 8 is 1 over 4. So right here, when I write this equation, this is going to have a 1/4 in front of the x. The amplitude is 1/3, but I hope you put a negative 1/3 in for a, because you didn't want this curve to start up here and come down. You wanted to start at a negative 1/3. Again, what's my function? And this equation would match this curve. We'll go ahead and trace the curve in class as well with the graphing calculator, but you could put it in. Just know that your window here, 8 times 3.14, is a little bit more than 24. I would probably open my window from 0 to 26 or something, and then in the y direction I hardly have to open it to maybe a third or 2/3 maybe. So a negative 2/3 and a positive 2/3, I could open it. I'm going to come back and do these applications in one more video, and we'll have mastered the concept of y equals a times the sine of bx and y equals a times the cosine of bx in our study of the graphs of these two trig functions.